So this entire unit is called trig functions, because now that we've learned about trig as a ratio, like sine, cos, and tan, we're going to learn how to graph it and what the function actually looks like. So it's a really nice continuation from the previous unit. Today we're going to talk about two different things: what is a periodic function and what the graphs of sine and cosine actually look like. All right, so let's get started. Here is the first part, periodic functions. If you've done physics, by the way, these words will be very familiar to you. And if you haven't done physics, it's okay. They're not too difficult to learn. So here I have a shape of a graph that is a periodic function. And what it means is a function is periodic if it has a pattern of y values that repeats at regular intervals of x. So what that means is from one x to the other, you'll have a certain shape, and then that pattern is going to repeat for another certain values of x, and it'll repeat and repeat. So you're basically looking from left to right to see if the pattern repeats. One complete pattern is called a cycle. So usually you look at any starting point, and then you look at the ending point, and from the start to the stop, it's known as a cycle. A cycle may begin at any point on the graph. So you determine where the cycle begins by just drawing a point or circling it, and then you follow through, and then the next cycle will begin at the exact same position. But everyone can have a slightly different answer. So for example, I can say, all right, my cycle begins here, and then it goes all the way and it ends over here. Whereas someone else may say, no, the cycle actually begins here, and then it goes all the way and it ends here. So a cycle can be different from everyone, but in the end, you'll still have the same repeating pattern in terms of values. And then the last definition is a period. A period is known as the horizontal length of one cycle, and that's called the period. Okay, so three definitions: cycle, period, and periodic. Okay, so let's try question number one. It says, determine whether each function is periodic. If it is, state the period. So we begin with graph A. What do you guys think? Is this a periodic function? Does it have the same pattern repeating for a certain value of x's? It seems that it does, but look, here is the starting point, and let's say this is the ending. The next starting point is actually not in the same position as the previous one. For something to be periodic, it has to have the same horizontal position at beginning and end. So we're going to say this is actually not a periodic function because it doesn't have the same pattern of y values that repeats at regular x values. Okay, let's look at the next one. So let's say I begin my pattern here, I follow it through, and then I go here, and then I begin the next pattern here, and I follow through, and I end there. Is this a periodic function? Yes, it is. And we know this because it has the same start and stop point horizontally as the next one. And if you look at either one of these W's, what would be the period for this? What is the horizontal distance from start to stop? How many units could you say? So if we start here, it's from 0 and it goes all the way to Sarah? Yeah, so we're going to say yes, and the period is 8 units. Okay. A couple more definitions. There are quite a few definitions for this first lesson. We're going to talk about the amplitude of a graph, and we're going to talk about the equation of axis. So I'll go through the definitions first, and then we'll talk about what it actually looks like on a graph. The amplitude is half the difference between the maximum value, which is the peak of the graph, and the minimum value, which is the trough of a graph. Now, because this is a periodic function, it will always have a maximum and a minimum, right? Because it has to have a repeating pattern. So what you do is you identify the maximum value, you identify the minimum value, you figure out what the halfway point is, and that distance from the halfway point to the maximum or minimum is known as the amplitude. There is an actual definition or an actual equation for it, and it would just be your maximum value minus your minimum value divided by 2. Hold on. Okay, so let's look at the graph and try to figure out how this works. The maximum value are all of these points over here. They're as high as it can get, right? And that's known as the peak. And in this graph, it would be the number 3. The minimum value are these low points. They're as low as it can go. And on this graph, it would be a -1. Now, even without doing the math, you can figure out that halfway between a 3 and a -1 would be approximately 1. So you can see that with the dashed line. And then you're basically telling me how many units are you going from the middle to the top and from the middle to the bottom. And they should have the same value if it's directly halfway. So in this question, from the midpoint to the top, the highest point is 2 units. And from the midpoint to the lowest is also 2 units. And so we would say the amplitude is going to be a 2. The amplitude always has to be a positive number. Okay, and actually it's drawn a little bit better over here. I'm just gonna erase all of this. What is the name of that dashed line? It actually has a specific name. It's called the equation of axis. And the definition is it's a horizontal line that is halfway between the maximum and the minimum. And the equation for that is maximum plus minimum divided by 2. Now, how do you remember the difference between these? They're so similar. I have a really silly way, but it seems to work. Amplitude to me sounds like attitude, and attitude can be negative sometimes. So if you're talking about amplitude, it's a minus sign, you think of attitude. And equation of axis will be a plus sign. Okay, so the math for the equation of axis, you're gonna have -1 plus 3, which is just a 2. 2 divided by 2 is a 1. And so we would say the equation of axis is that y is equal to 1. How many of you have done physics before? And have you learned these words in physics? No? Oh, maybe you're not there yet. But you guys do like waves, right? You're doing that right now? Oh, good. So there's a little bit of overlap. Yeah. Y is equal to, yeah. Okay, so let's try one example together and then you'll try the other one yourself. Here we have 2 graphs, so we'll do the one on the left together. Determine the range, the period, the amplitude, and the equation of axis for the following functions. So the very first thing I'm going to do is I'm going to try to identify where the pattern begins and ends. You pick any starting point. So let's say I pick this as my starting point. I'm going to follow it through all the way until I feel it begins again. And that is one cycle of your periodic function. Okay. The range is basically asking you how high the graph is going and how low the graph is going. So think back to when we used to do range properly. Range are the set of all y values such that, what are the numbers between on the y-axis? Like what's the highest point and what's the lowest point? Yeah. Yeah, did you say -2? So just look at the, yeah, just be mindful of the scale that they have there. I'm going to notice that this is actually -2, this is actually 2, and that's 4. This is a 2, this is a 4, this is a 6, 8, and 10. So it's the set of y values such that y is greater than or equal to -2, and it's less than or equal to 4, and y includes all real values. Okay, what is the period of this graph? So if you look at where I've drawn it, it begins at 2 and it lands all the way to 7. We're just going to assume that's a 7. So between 2 and 7, how many units have gone by? We're going to say the period is 5 units in length. What is the equation of axis? So we can do this just by looking at the graph, but also figuring it out using the equation. So let's look at the graph first. My maximum value is a 4. My minimum value is a -2. And just halfway between 4 and -2, where are you going to land approximately? There are 4 units there, 2 units there. So you want to go 3 units, and it's going to be? Yeah, it's going to be at y is equal to 1. Now, let's say we couldn't figure that out just by looking at the graph. The way you would solve that is you would add those 2 numbers together. So 4 -2 divided by 2. 4 minus 2 is 2. 2 divided by 2 is 1. So we would say the equation of axis is that y is equal to 1. We always want to show that on the graph as well. So I am just going to draw a straight dashed line at y is equal to 1. Okay, and then for the amplitude, again, we can just figure it out using the graph. If the halfway point of this periodic function is a 1, how many units does it take to get all the way to the highest point, and how many units does it take to get all the way to the lowest point? You would say 3 units, good. If we wanted to use our equation to figure that out, what would we do? We would say it's going to be 4 minus -2, because remember, amplitude is like attitude, it's negative, so you put a negative sign. 4 plus 2 is 6, 6 divided by 2 is 3, and so our amplitude would just be 3 units. Does this make sense? Yeah? Okay, go ahead and try the same stuff for the other example. Okay, and I guess I'll start by writing out my answers. So between 3 and -6. So it's going to be -6 and 3. Okay, and then the next one, oh no, I can't remember what color I used. This one? Let's try that. And then the 2 is going to be from the maximum, which is 3 to -6. So it's going to be 3 plus -6 divided by 2, which is just going to be -3/2. So therefore, our equation of axis is at -1.5. So we can actually go and write that in. -1.5 would be right there. The scale for this one is super weird because it's actually going up by like 1.5. And then the amplitude would be 3, well, the max 3 minus -6 divided by 2. So it would just be 9/2, or you could say 4.5 units. All right, so question number 3. The automatic dishwasher in a school cafeteria runs constantly through lunch. The graph shows the amount of water used as a function of time. Let's look at this example, and can you explain why a dishwasher is an example of a periodic function, especially if you're talking about the volume of water coming in and leaving the dishwasher? Anyone here know how dishwashers work? Marzouk? Yeah, exactly. So what happens is, from my understanding of dishwashers, you first have the initial water that comes in, it does the first like pre-soak, then you have the soap and all of that stuff, then it does another soak. So there are multiple different times that water is coming into the dishwasher and then it's leaving the dishwasher. Good. So explain why the operation of the dishwasher is an example. I guess we could just say it turns on and off at regular, it fills up and drains, or however you want to talk about it. I'm going to say it fills up and drains at regular intervals. Question number 2, what is the length of the period? What does one complete cycle mean in the context of this question? So if we were to just identify what's happening in this graph, we're going to notice that, let's say our starting point is here. We fill it up, then it stays in there, then it drains, then we fill it up again, it stays there for a bit, and then it drains, and then it stops. So I would say that is one complete cycle, The second cycle would be it fills up and then it stays there, it drains, it fills up again, the water stays there, it drains, and then it stays empty. So this graph, you can see there are 2 cycles of the dishwasher. What is the length of one of the periods, approximately? Being mindful of just the scale. What do you guys think? Yeah, 14, and we actually have a unit for this one. It would be 14 minutes. Good. What does one complete cycle mean in the context of the question? It just means the dishwasher goes through a cycle and then you like load it and it does it again or something like that. So I would say the dishwashers run through one cycle. I do have to warn you, this unit does have quite a few word problems because now we're basically going to be talking about like sine and cosine in real life situations. Determine the amplitude and the equation of axis. We could use our formula or we could just use common sense. Maybe we could do a little bit of both. So I recognize that in this question, our maximum value is 15 and our minimum value is 0. So for the amplitude, you're going to go 15, take away 0 divided by 2. And that's just going to give us 15 over 2, which is the same as 7.5. Okay, so if we were to put in our amplitude, that means from the midpoint of this periodic function to the maximum, it's 7.5 liters. And from the midpoint to the minimum, it's 7.5 liters. Let's figure out the equation of axis as well. So to do that, we're just going to take the maximum and this time add it. And it just ends up being exactly the same. So the midpoint of this graph is 7.5 liters. Okay, I know you can't see that. I'm going to make it a little brighter because actually I can barely see that. Whenever the graph does ask for or talk about an equation of axis, I do like to put it onto the graph. So I'm just going to turn my graph around, figure out where 7.5 is, and I'm going to make a dashed line throughout. Okay, and then just somewhere along the graph, we're going to put y is equal to 7.5. Question D says, extend the graph for one more cycle. So we're going to just follow the pattern and extend this graph for one more cycle. How am I going to do that? Well, I just follow along. So the first like diagonal line goes all the way up to 15. So here's a starting point. And then that's after 1 minute, it goes up all the way here. Then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 for approximately 6 minutes. It stays in the same position. Then it goes all the way down. Then it comes all the way back up. Then 2 minutes, it stays filled up. Then it comes all the way back down. And then for 2 minutes, it stays there. I don't want to see you guys. So hopefully you guys used a ruler to draw yours. I did not. If we know each cycle or each period is 14 minutes and the second one ended at 28, what do you think the next one will end at? We're just going to add 14 to 28 and we end up with 42. So here we're going to be at 42 minutes. That's when the next cycle is going to end. And if you wanted, you could actually put in the rest of the numbers as well, just to be consistent. All right, last question on this page. Question E. How much water is used if the dishwasher runs through 8 complete cycles? All right, so to figure this out, what we're gonna have to do is we're gonna have to figure out how much water it takes just to run in 1 complete cycle. So 1 cycle, let's see how much water it uses up. So from 0 to 14 minutes, you fill up with water, that's 15 liters, then it drains, then it fills up one more time, that's another 15 liters, and then it drains. So in 1 cycle, how much water have we used up? 30 liters, good. And so therefore 8 cycles will use up how much? 240 liters, good. Okay, that's actually the end of the first part. For this part of the lesson, the questions you want to try are page 352, numbers 1 to 10. So just highlight those for yourself. And then we're going to just move on to the next part, which is again very short, and then we're done.